A lot has been happening around the world in the last 6 weeks or so. I'm not entirely sure what could have changed 6 weeks ago to have such a startlingly negative impact. Answers on a postcard. And that's led us to have to shift some of our usual output to tackle and dissect important news stories that we think impact the world of cleaner, greener, safer, smarter and more equitable vehicles and transportation. And who knows, by the time this video goes live, it may have been pushed back or delayed a few times for breaking news stories, or it might have just been pushed a few days after its edit was complete. I can't time travel or tell you. An immortal time-travelling doggle will have to do. But either way, I want to make it abundantly clear that this video right here is not about politics per se, but rather about addressing a comment we've heard time and time again in response to videos discussing new models coming to market. And that comment, obviously I'm paraphrasing all of them, is that automakers are fools if they make 400-volt EVs in a world where 800-volt is the new and shiny. It's a sentiment we've seen a lot in the last few years with increasing regularity, and it's one that popped up a few weeks ago when we covered Kia's unveiling of its EV4 for the first time. Some folks were incredulous that the Hyundai Motor Group, which owns Kia, Hyundai and Genesis marques, would unveil a brand new 400-volt EV in the form of the EV4, when the brand's eGMP platform to date has primarily focused on 800-volt architecture. So today, I want to examine the reality of differences between 800-volt and 400-volt vehicles, discuss the advantages and disadvantages of each, and ask if you, as an EV buyer, should get your next EV as an 800 or 400-volt vehicle.
But don't ask me. I have an airship.
In today's video, I'm going to be featuring a bunch of different footage of EVs that we have captured over the years. Traditionally, if it doesn't have a B-roll credit attribution in the lower left corner, then it's one we made in-house. And without blowing our own trumpet, I think we have the largest in-house B-roll library of any EV YouTube channel out there. So if you'd like to help us continue to grow that library, stick around until the end when I'll tell you how to support this channel. Oh, and also I should remind you that we do production work for non-EV stuff. So if you'd like our pretty pictures used and a production crew for your company, we might be able to help. Usually, we'd not add any extra indications on screen, especially for our own stuff. But to make today's video really easy to follow, we're going to add 3 little badges to our B-roll to let you know which vehicles use 400-volt batteries and power electronics and which use 800-volt batteries and power electronics. You'll also see a note on screen if they are split 400-volt vehicles capable of charging at 800 volts, because there are a few models that do this. So keep your eyes open for those badges as we go through. For nearly a decade, the overwhelming majority of EVs on the market made use of what the industry terms 400-volt system architectures. Why is it 400 volts? Well, it's a rough representation of the half-empty pack voltage of some, but not all EVs on the market. Since each automaker uses slightly different cells and pack designs, the actual battery pack voltages between vehicles vary slightly. So we really should take the term 400 volts with a metaphorical pinch of salt. Just don't get them near the battery terminals, unless it's a sodium battery. For example, the Nissan Leaf is considered a 400-volt EV, but it has a total nominal pack voltage of around 358-ish volts and a full pack voltage of 398.4 volts, so not quite 400. Some other EVs, also in the 400-volt club, operate at slightly higher voltages, but they're all considered 400 volt. All of these vehicles have inverters that are capable of taking the approximately 400-volt battery voltage and turning it into 3-phase power to drive their motors and move themselves along. Those same inverters can recapture energy from regenerative braking and then feed it back into the battery pack for later use. And as long as they have DC fast charging capabilities, they all use similar fast charging technology to dump high current DC power into their battery packs at a compatible fast charger. 800-volt vehicles, as you might have guessed, operate at a voltage that's closer to 800 volts, although the same caveats apply that we outlined for 400-volt vehicles. 800-volt EVs have battery packs that operate at 800 volts DC or thereabouts. They have inverters that are designed for higher voltages of an 800-volt system architecture and are designed to work with 800-volt DC fast charging stations. Except, and this is where it gets a little clear-cut, most EVs that are built on 800-volt system architectures are capable of actually using 400-volt charging stations. And some based on 400-volt tech can actually use 800-volt charging stations. That's because most, but not all, 800-volt based EVs are able to reconfigure their battery pack either by using a charge booster that doubles the voltage while halving the charge current, or by physically splitting the battery pack in two and then connecting the two halves in parallel for 400-volt operation, as opposed to having the pack in series, which is what gives you 800-volt operation. Some EVs even do the opposite. If they're based on 400-volt battery packs like the Ultium-based Hummer EV and Silverado EV, they are actually 400-volt EVs that fake being 800-volt EVs when they need to charge more quickly by then putting that battery split trick the other way round. Now we know what the differences are between the 400-volt and 800-volt architectures, let's examine the why and detail what the general switch in the EV industry towards 800 volts is actually about. But first, some electrical engineering. Without taking you to a physics lecture, electrical power, the thing we measure in kilowatts in an EV, is the product of voltage times current. When explaining these terms to those who aren't into engineering or science, it's fairly common to imagine that a wire carrying electricity is a little bit like a hose carrying water. And if we keep that analogy going, voltage is a little like water pressure, while current is a little like how big the hose is, and the resulting power is a little bit like the amount of water we can get out of the hose, its flow rate. If you live somewhere with a low water pressure, you need a large hose to get a lot of water moving in a given amount of time. And if you have a small hose, you'll need higher water pressure to get the same amount of water flowing out of the end of the hose in the same amount of time as you would with the larger hose and the lower water pressure. When it comes to electricity, the same is true. For a given amount of power output, your voltage and current are inversely proportional to one another. If your pipe, your electrical cable, is capable of delivering a large amount of current, you don't need a very high voltage for a given power output. But if your cables are small, you'll need a higher voltage for the same power. So far, so good. But electrical cables, just like pipes, will resist the flow of electricity like a pipe will resist the flow of water. The larger the pipe, the easier it is for water to pass through, and the thicker the cable, the easier it is for high currents to pass through. But even then, as you increase the current flowing through a cable, you'll start to see more and more of the electrical energy lost due to electrical resistance, the name given for the wire's reluctance to allow power to pass through it. The higher the current you need to push through a cable, the physically larger that cable usually needs to be to overcome that resistive loss. And here's where 800-volt EVs start to make sense. For a given power at the wheels, you need 1/2 of the current in the cables at 800 volts when compared to 400 volts, which means if you're building an EV, you can use thinner, lighter cables at 800 volts than you would at 400 volts. And that can save you weight, and since the weight you're slashing comes from expensive, often copper wire, you also get to slash manufacturing costs. Also, in some cases, you get to improve vehicle efficiencies because, as I just discussed, the lower a current and the higher a voltage, the less losses you'll find in cabling due to electrical resistance. But it goes much deeper than that. Battery packs operating at higher voltages are also put through less strain for a given power output than they would at lower voltages. Again, the higher the current you try to pull out of an EV battery pack, the more likely it is that individual cells within the pack will start to sag as they reach the bottom of their state of charge, which in turn is more likely to unbalance cells within the pack. So, if you pick an 800-volt battery pack, you need lighter cables for a given amount of power, which means they're often smaller in their physical characteristics, and therefore can fit in smaller spaces. You lose less power due to electrical resistances, and your batteries will likely have a much less stressful life if they are part of an 800-volt battery pack when compared to a 400-volt battery pack. But the benefits don't just stop there. They go further, especially if you have a high-performance EV. One of the biggest challenges when it comes to building a high-performance vehicle is to ensure that the vehicle's performance remains pretty similar, regardless of what the vehicle's state of charge is. And if your battery pack has a higher voltage, those sudden dramatic power spikes when someone buries their right foot to the carpet will result in less voltage drop for the cells, meaning you'll be able to do those stoplight sprints again and again and again. And if you're spending 6 figures on a shiny new sports car like the Porsche Taycan, especially if it's your first EV, the chances are you'll also want charging sessions to be as quick as possible at fast charging stations. 800-volt battery packs give you that. The higher the voltage, the more power you can jam into a battery pack for a given cable size, and CCS charging station plugs are capable of transferring really high currents with relative ease. Say what you will about CCS and how much you think NACS is so much better, but those big boy pins at the bottom of the CCS charge inlet are there for a reason. High current, high voltage DC charging. Sure, NACS does have them too, but for quite some time CCS had a power advantage over NACS thanks to the larger surface area of those 2 DC pins and the cables that connect to them, alongside which CCS has space in the plug to provide cooling, something that NACS hasn't effectively been able to do. Just like 800-volt batteries are put under less strain in use due to internal resistances, so too do they benefit when fast charging, as even if they're operating at higher power levels than is possible with, say, 400-volt battery technology, you're generally still charging at lower currents, meaning less battery heating, less cable heating, and less need for on-board vehicle or even charging station cooling. So if higher voltage is better, why are not all automakers using it for all of their vehicles? Why are companies like Kia producing 400-volt EVs when they actually have a capable 800-volt platform like the majority of the eGMP lineup? And the answer is, well, 400 volts is enough for most people. It's also an older technology, and that means it's more proven. Automakers really like to pare down their vehicles to have as many shared components as absolutely possible. It helps save costs, and in a world where toddler politicians decide to add random tariffs on vehicles because someone let them have access to their big boy box of crayons and some headed note paper, saving money is super important for automakers and super important for us as consumers. The smaller a vehicle is, the harder it is to build an 800-volt battery pack to put inside of it. If you are going to use a reasonably standardized cell design, that is. And if you're trying to save money on production costs, designing a platform with the capability to operate in either 800-volt or 400-volt means more flexibility in production. Take the GM Ultium platform, for example. It's a weird one because it's not actually an 800-volt vehicle. Its battery pack is set up for 400-volt operation when driving, but can pretend to be 800-volt for charging. It uses the same battery cells as other Ultium-based EVs that can't do its special 800-volt switcheroo, meaning GM can pick and choose which vehicle it wants to use cells in. And that means if your big, massive pickup isn't selling well, you can put those cells in your crossover EV without dramatically changing your cell production process. In fact, you can make more of those crossovers than pickups for a given battery output, so it's a win-win. But then there's the other components that you're going to need to make your EV work. 800 volt is still considered cutting edge, and parts suppliers and automakers have less experience designing and manufacturing them. That translates into higher production costs, increased likelihood of defects, and that can all flow down to the consumer. Just look at the challenges GM had getting its Ultium platform to market, many of them because it's a 400-800 volt split system. 400 volt EV power electronics are frankly pretty robust these days, from power contactors to DC converters for your car's 12 volt system. They are all available in large volumes at low costs, and most tier 1 automotive parts suppliers have a model or two that will fit your chosen application. And then there's charging. And while I know there's something magical about pulling up at a fast charger in a fancy new 800 volt EV and charging from 10 to 80% full in less time than it takes to go and pee and grab a lovely beverage for the road, it's only really of benefit if you happen to be charging just once on your trip, or you are road tripping with multiple people who can take over the driving duties. As I recently detailed in my own road trip video just last month, driving 610 miles in a day, stopping every few hundred miles for 20 to 40 minutes to charge, was about my limit. And on the second day of my trip, I actually chose to stop somewhere to quote-unquote fast charge my F-150 Lightning, which, by the way, is a 400 volt EV, at a rate that was slower than the maximum charge rate that my truck could manage, because I knew I needed a longer break from driving than I would get if I stopped at a charger that could actually max out my truck. The other thing that isn't talked about so much is that 800 volt charging is a little picky from time to time. The higher the voltage, the less room there is in the system for error, and while 800 volt charging is now a lot more reliable than it was a few years ago, anecdotal evidence still suggests that 800 volt charging sessions are more likely to suffer random isolation faults and other gremlins because of higher voltages and the associated safety protocols that come with that. Which brings me to the question of, should you go with 400 volt or 800 volt? Honestly, the answer depends on your personal needs. If you are an EV driver who needs a high-power EV and you are after sporty performance and quick charging and quick acceleration, regardless of the price, 800 volt probably makes sense for you. And if you are someone who is a bit of a road warrior, either for work or pleasure, and you require as efficient a vehicle as possible and as short a stop as possible to charge, go with 800 volt. But if you are just in the market for a car that gets the job done, can fast charge when you need it to, and carry out your daily driving duties with maybe not that frequent fast charging trips, yes, while it might take longer to charge on the road, it's a pretty solid option to just go for a 400 volt vehicle. Right now, 800 volt technology is frankly still a premium feature. And one day soon, I do expect it will be a standard for all EVs. But at the end of the day, you need to ask yourself if you're happier with super fast charging or a significantly lower price tag, because right now, that's probably the real answer. Personally, I own two EVs, the Bolt EV and the F-150 Lightning with 400 volt technology. Right now, I'm not interested in switching either of them out just to get a faster charging experience. And my third EV doesn't even have 400 or 200 volt technology. It's actually closer to about 136-ish volts nominal and about 148 volts nominal after I've done its nickel metal hydride to lithium ion upgrade. By the way, check out the video we published last week on that one if you haven't yet. When it comes to my Vectrix, I'm honestly all about total cost of ownership. And while fast charging would be nice, that bike doesn't have that and never had it as an option. Although rumour does have it that some enterprising folk are trying to utilise Toyota hybrid components to make that possible in the not too distant future. But that, I fear, is for a completely different video.
I wonder if it will fit in the ship. Must do.
Thanks for joining us today, and if you've got thoughts, make sure you leave them in our Discord room, on our Patreon page down below, or you can reach out to us on Mastodon or Blue Sky. Thanks to the amazing list of people scrolling by on your screen right now. They're part of the massive community of supporters who make this channel possible, helping us through Patreon and YouTube. That allows us to cover our bills, pay our team, and also ensures that we remain 100% independent. If you'd like to join them and see your name listed here, just follow the links below. We've got options available across a wide range of different price points, starting from $1.50 US a month. A massive welcome to our newest supporters: Eric Mora, Jordan Roy, Joseph DeViver, Scooted, Rennie Schweiger, Robert M, and Lev P. To join the list and get your shout out, become a paid Patreon member for your moment of fame, and you can now even gift membership to someone else. If you'd like to support us with a one-off donation, you'll find links below to make Ko-fi and Bitcoin donations, and we even have a good old-fashioned PO box you can reach us at for the time being, address listed below. You'll also find links to our swag store, and if you're someone who has to shop on Amazon, please consider using our affiliate link so that we get the commission instead of Jeff Bezos. So we can continue to focus on making our content even better and reduce creator burnout. We're being a little freer with our release days, but plan on dropping new content every Tuesday, Thursday, and Saturday on our main channel. Plus, on a Sunday, you'll find something over on Transport Evolved Take 2. If you want more, the algorithm that hates us thinks that you should watch this video, but we also think that this one is well worth checking out. Be awesome, be kind, be intentional, and don't forget to resist. Keep evolving.